Hello and welcome everybody. My name is Michal Fousek. I am iOS team leader at Showmax company, and today I will tell you a story about dependency injection and our team and how this thing evolved and what we used and what we started using and stuff like that. Something a little bit about me. I started with iOS development in the year 2008, somewhere between iOS 2 and 3. And I've been working in Showmax for the last 6 years. So what is Showmax? What Showmax does? Main business of Showmax is streaming of a video, and main primary market of Showmax is Africa. So unfortunately, you can't use our service from Czech Republic unless you have like South African credit card or something like that. Basically, it's bad to say, but we are something like Netflix. Our customers pay a subscription fee, and they can watch movies and series, and we also offer live streaming of the sport. So, for example, recently our customers were able to watch the whole Olympic Games through our service. And if you would like to know more about us, check our tech blog at tech.showmax.com. Okay. So, who knows what is dependency injection? Okay, great. That's good. You probably very easy though. So, next point is what is dependency injection. So I will do it fast because you will know it. I won't bore you. It's technique that that is technique when the object doesn't create its own dependencies, but those dependencies are created outside and then injected or passed to that object by some method. Here you can see example of a code when dependency injection isn't used because we have some model class and that class has some whatever manager and that is its dependency. And our some model class is creating the dependency and then using it. Here we are not using dependency injection. At this example, we are using dependency injection because whatever manager isn't created inside some model class. Yes?
Yes, but it's very hard to see it.
Okay. To be honest, I really don't know. Maybe be on the wall. Make it brighter. Možná jak je to pro všechny moví, jak to přepnout, protože to vypadá, že by to mohla být moví. Tak já to zkusím. Jo, thing is that if you copy the code from the Xcode, the colors are not copied correctly to the presentation. So it took me a really long time until I said the course like this. Okay, so let's continue. Thank you everybody that you had this situation. So this is example when we are using dependency injection. Whatever manager is created outside of some model and it's passed to some model via constructor, and some model just use it. And why you won't use the dependency injection? One of the reasons is that it decouples creation of dependencies and usage of them, because at this case, some view model you care how to create whatever manager. In this case, in this example, it's super easy, but it can be super complicated. It can be more dependencies for whatever manager and stuff like that. At this case, some view model doesn't care about how whatever manager is created, it just gets its instance and it's used it, and it's super effective. And the second thing is, it's almost must-have when you want to write tests. Why? Because if you use dependency injection, you can, when you're writing tests, you can inject more instances of your real implementations, and you can basically control what is happening, set up conditions, and then test different conditions however you want. Without dependency injection, it may be possible, but it's probably super hard. Okay, so now back to our story. Long time ago, our code looked like this. We were using singletons, a lot of singletons, directly in the code. Singletons aren't bad by themselves, but those can be misused, like really bad misused, and we were doing it. And it was almost impossible to write tests and to manage code like this. It wasn't super nice. Okay, so we decided we want to write tests and we wanted to do dependency injection. So what solution did we use? We decided to not use any big dependency injection framework because we want to do as simplest thing as possible. So basically, every object that has dependencies has some dependency structure, and this dependency structure has a list of all the dependencies. And when creating the object, first outside of object instance of this structure is created, and then it's passed to that object via constructor. You can see the example of this on the bottom right corner, how it's created. In this case, we are using singleton, but it's good usage of singleton because we have dependency injection, and when writing tests, we can inject more instance of whatever manager instead of that singleton, basically, and we can control what's happening there. We started doing one more thing, which is super important here, and we started using protocols. If you look at the right corner, you can see whatever manager is now class. On the previous slide, it was class. Now it's protocol, it's not class. And then we have some class called whatever manager info, which implements that protocol. And basically, almost every public type in our code was defined by protocols. And we were using those protocols almost everywhere in the app. We weren't using the specific types. And thanks to this, we were able to set up sorcery and start automatically generating mocks for those protocols, and writing tests becomes easier. So we achieved our goal here. But after some time, we found one disadvantage, which became pain in the ass. The thing is that if you want to update dependencies for some new model, you have to change the dependency structure inside it. And it means that you have to go through the code and change how you create that structure everywhere where you create it. So if you have multiple places where instance of dependencies is created, you have to go there. If you have some factories where it's created, you have to go there. And it becomes really uncomfortable. So how we we started researching some dependency injection frameworks, and we weren't happy because either we would have to solve optionals or handle exceptions when resolving dependencies in almost every major dependency injection framework. And we were comfortable with this. But one day, one of my colleagues found an article and speech from the iOS engineer from Lake. You can check the links from the QR codes. It's viewable, I don't know. I hope. And they presented their solution for dependency injection, and we loved it. So we started using it. So it's not our idea. We take the idea from Lake, we modify it a little, and start using it. We call it Simple DI. I think they also call it Simple DI, I'm not sure. It means Simple Dependency Injection, right? And the great thing is it's only 60 lines of code, nothing more. And it has built-in support for modding. So this is the magic. Basically, you have one enum, which is here used not like typical enum, but more for namespace definition. And you have three functions and two dictionaries. And basically, you use bind function to provide type and the closure, which is able to create instance of the type. And this is stored in the dictionary. And then you get back the closure, which you can call anytime you want, and this closure will give you instance of the dependency. That's bind method. I will show you the usage of it in the next slide. And then when you want to write tests, you just mock method in almost same way as bind, and the simple DI is clever enough to know if it's running for tests or not, and then use the right dictionary to create instances. If you would like to see the real code, check the article or the speech. Like it's that basically. We didn't do much. We just started looking for thread safety and use it. Okay, so how do you use it? If you want to add option to resolve new dependency, you add extension to the DI enum. You create a variable, and you call the bind method. You provide a type, you provide a closure, how to create a type, and you store the result into the variable. And then if you want to resolve the dependency, you simply call di dot name of your closure, and that's it, your dependency is resolved. Here you see that we still have the dependency structure. We don't have to have here. But we found out that if we call di dot whatever anywhere in the code, we create a mess very soon. So we decided to keep this structure. So every object has one point where you can find list all dependencies there. So if you then go and write tests, you can easily find out what dependencies you have to mock for that object. And on the right bottom corner, you can see how easily you create some new model now. Just both constructor and dependencies are resolved automatically. Okay. Any question here?
Now, this approach allows you to have like runtime arguments.
Yeah. It's basically up to you how you implement that closure, which provides you the instance. Like here, it's simple code, you just use the singleton. But what you write there, it's really up to you. So you can call any code there. It doesn't support to provide parameters to the get whatever manager method, if you meant this.
Yeah, like some input from the user and
Yeah.
at the runtime.
Yeah. No, I think the answer is no.
you have access for your dependencies inside your some view class or instance, and you can access any dependency essentially at the time.
Yes.
So you can pass the inputs to your dependency anytime you want.
You would
Yeah, actually, because it's closure. Into get whatever manager is stored closure, which is returned from bind method, right? And this is generic implementation for any dependency you have. So you can customize that. So you can pass parameters to get whatever manager. I'm thinking why is it a problem? Like, your dependency can have other dependencies, and dependencies can bring that input, right? Like, if whatever manager has some configuration file or configuration object, that configuration object can be again treated as dependency and available to BI and can be used as input basically.
Example, you have like a user which is on a release version or the staging version, and then you will pass to the dependency the question is the live version or not. But this way, you have the dependency inside the dependency, you don't know what kind of user it is.
Okay.
Because it's very, for example, user puts in login password and then you check if it's live or not, and then, but you
I can probably imagine right now the real world example.
I think it's more about architecture now.
Yeah.
You use your entities and your objects.
The great thing about this is it's super small and it's doing only its thing. And the huge disadvantage of this is it's super small and doing only its own thing, right? Like in our case, we didn't have any issue with that about it. We can probably talk later about some specific examples, and I can tell you how we solve that or how we're solving it in our application right now. Okay, so let's continue. The great thing about this is if you keep the dependency structure, you can combine your approaches. You can still use this manual approach. You can have like manually created dependencies in that structure, and you can combine the automatic layers of dependencies if you want, if it fits your case. At some places, we are using it. Okay. And this is example how mocking works. Basically, I expect that I have generated some mock, which is called whatever manager mock. That mock implements whatever manager protocol. And I call mock method from BI. I provide whatever manager type, and I tell BI that it should use whatever manager mock instance when running tests instead of real instance, right? And then the rest of the code is same as in application. I just create some model, and when it asks BI to resolve the dependency, BI automatically use the mock instance instead of real instance. And super important is to call unmock all when the test is done. Do not keep any old mocks in there because you could have unexpected behavior in the next test or that's probably it. Any questions? So advantages and disadvantages. What we learned. Advantages are that it's a super small piece of code. It's not another framework. It's not another huge third-party dependency. It's easy to use and easy to learn. If you would like to use it, you don't have to use it in the whole application at once. You can use it gradually, or you can use it only at some places as it fits to you. It's flexible. It's doing only its own thing. So it's up to you how you use it. Do you want to use singletons? Hey, use singletons. You don't want to use singletons. Don't use singletons. You want to have dependencies at one place? Do it. You don't want to do that? Don't do it. Simply iOS is happy with that. And it's built-in mocking support. What are the disadvantages? It has no compile time check if all dependencies are satisfied when mocking. So we updated the simple EI code. So now if we run the tests and some dependency isn't mocked, it won't use the real implementation, but it will simply crash with a fatal error. And because there is no compilation time check for this, it may happen that you don't mock all the dependencies, you run the tests, it crash, you mock the dependency which was missing, you run the test again, crash again, and so on until you mock all the dependencies. But if this wouldn't fit you, you could probably update the simple DI code and change the behavior of a few lines. It can be misused. This is the reason why we kept the dependency structure. We found out that if we call DI anywhere in the code, however we want, it becomes a mess, and we didn't have like one place where all the dependencies are defined. It was hard to find what are those, and it was hard to move them all and stuff like that. And it doesn't have advanced features like other big dependency injection frameworks, but in our case, it wasn't a problem. It really depends on what you need, because for us, it does exactly what we wanted. Yeah, and that's for me. Any other questions?
So you said you had a problem where people were misusing the DI, like accessing the DI. You said you solved it by bringing the dependency class or whatever.
Yes.
Is there a way to force people to just use you cannot use the DI outside of the stripe?
Probably there is not. We just agreed on this rule and everybody started doing it. Like we didn't have this. Actually, we have one exception to this rule, as there is exception almost to any rule. We have some kind of system that corrects the local date, because we found out that local devices on which our application runs have wrong time, like sometimes even by a few days, and it was a problem. So we start synchronizing the date with the server date and computing this and stuff like that. And now we have, I'll show you that. Yes. And we have something like this. And if you use DI date, it's something like if you create new instance of the date class, and you are allowed to use this anywhere in the code, because it's basically a replacement for creating data for us. So otherwise, we are using dependency structure almost everywhere, and it's not a problem because everybody likes it. And if I'm in this code, I can show you the it's really not magic. It's a few lines of code, and that's all. Yeah. This is it. This is the whole thing. Basically, you store the type and the closure in those dictionaries, and there is a one function which is returned from the find method or pointed to this function, and this thing just use the dictionaries to resolve the dependencies.
So it's only one copy of the dependency. You cannot have
It's really up to you, because if I would do this, then every time I call the date, I get new instance of the date. So it's really up to you how you create the closure which creates the instance. It's up to you if you want to keep like one instance for everybody or create an instance every time.
I meant that in the code you
it's set as a parameter in some other scheme. It's like it's our thing. It's lunch arguments provider. Yeah, it's reading lunch arguments. Like you can. It's super simple, right? You can do it as you want. That's great about it.
Is there a way to mock up individual methods of the dependencies, or you have to mock them?
No, we are using sourcing, and I can show you. These are the protocols that we want to mock. Yes, and these are like generated mocks. So it basically generates you set of things for every method, every property, and you can then work in it in the test. And this is not like connected to simple DI. This is just something what we use. It's up to you how you do your mocking, right? Okay. Any other questions?
You said that you go get a bunch of dependency injection solutions and you didn't like it, so you basically wrote your own. Did you take a look at switching?
Yes.
And what did you like about it?
Because you have to handle optionals when resolving dependency. You basically tell swingjack when you're resolving dependency, give me instance for this type. And if swingjack doesn't know how to create this type, it gives you nil, basically. So we would have to somehow handle these optionals for every dependency, and we really don't want to do this because it didn't fit to our previous method, right? Like we were trying to find something which wouldn't be maybe completely new, and we wouldn't have to rewrite the whole application or change the approach completely. So we found this; it was compatible with our dependency structure. We found out that, and it was super nice.
And one more question, you're obviously using Surcery for mocking. There's at least 5 different mocking frameworks available. Some of them use Surcery and Did you take a look at them and decided that you don't really use
No, because basically one of my colleagues used Sorcery and we said, okay, this is really nice, it suits us, and we stayed with it until now. So we didn't do any research, we just did Sorcery. Okay, if that's all, then I thank you and I hope you enjoyed it.
Thank you.